Okay, so let's get started. We're going to be taking a look in this tutorial at our pre-crank, cranking, post-start, and warm-up enrichment fueling and how it plays a role in getting the engine to crank, fire, and run with our linked G5 and G4X systems. So what we'll find is we have multiple different tables that we can adjust to get the desired crank to fire results that we're after. And when the engine's actually coming up to operating temperature, we can get proper fueling. So there's a couple things to unpack here just to understand why we're using these specific tables and why there's a need for all of the various tables that we have to adjust. And then we're going to be talking about the flow of logic in terms of how the tables actually work together. And then we'll take a look at some data log examples. So we can take a look at a cold start and a hot start on a fairly well-tuned calibration file to see what that should look like. All right, let's jump in here. We're going to move it from our basics page and we're going to jump over here into our fuel trim page, so F trim. And here we find all of the tables or parameters that we need to adjust our cranking fuel, our post-start fuel, and our warm-up enrichment fuel. Now, let's take a quick look at a graph that Link provides that ties together all the various tables that we have to work with. So fundamentally, let's look at the flow of logic of how the tables fit together and all the different parameters we have in here to program. Then we're going to talk about what each one represents individually. All right, so coming up on screen, we have our graphical plot. We're going to find on the left side axes, this is going to be the percentage of enrichment. And on the bottom axes, it's going to be time. So moving across in time. At the 0 time, that would be where we first initially just turn the ignition key on and allow the fuel pump to prime. And then we can see as we move across the bottom axis, we're finding that the engine then would be fully warmed up at the very rightmost time portion of our axes. So let's now start off in the very beginning and understand how this is going to work. We first have what's called a pre-crank prime. We can find that's up here in our upper window. Right now it's currently set to off. What this is going to do is prime the combustion chamber with a big shot of fuel before we even crank over the engine. We'll talk about the programming specifics here in just a little bit, but this is going to be used to prime up the combustion chamber. This would be the same thing as a prime feature on a carburetor. The next thing we find is our first crank enrichment. This is going to be a larger injector pulse that we send to the injector for the first cranking revolution as the engine is cranking over. Oftentimes this helps an engine get fired off for that very first couple cranks. Once the engine goes through the first cranking revolution, it'll move then to the crank enrichment table. That's what we find right here. So the crank enrichment table is going to be taking a look at our main fuel table, specifically at the 0 to 500 RPM range at 0 MGP. So that's going to be what it references. So if we just go over here real quick to fuel, it's going to take a look at this area right here. This is going to be our cranking area. So it's going to take the values that we find right here, and then it's going to be multiplying it based on what we find in our table value here. That will get us an injector pulse width under cranking conditions. Now we use the cranking table in terms of our cranking pulse width as we're cranking the engine over until the engine actually starts to fire off. Above 400 RPM, the link is going to consider the engine to be running and to exit the cranking table. Below 400 RPM, the link's going to consider the engine to be in cranking conditions, and it'll continue to use our cranking fuel value to supply the pulse width to the injector. So hopefully it's very clear that kind of tipping point. It's 400 RPMs or higher, it moves into the normal air and fuel model. 400 RPMs and below, it uses specifically the cranking enrichment table. All right, now what we're going to find, the next thing here is our crank hold time. The crank hold time is specified from our table right here. The crank hold time is going to be a period of time in seconds. We can find that designated here. That's going to hold our cranking enrichment even after the engine technically has exceeded the 400 RPM flare as it's starting to fire off and run. This ensures, this crank hold time table ensures that we have a smooth transition from our cranking enrichment into what's known as our post-start fueling. And we can find that taking a look here in our graph, we're going to see that there's going to be a post-start enrichment that's applied. So couple things with the post-start. We find that there's the post-start enrichment, there's the post-start hold time, and the post-start decay time. Now the post-start is used to stabilize combustion right after the engine is fired off for the first typically 5 to 20 seconds. When that short period of time, we'll find that we usually have to put a little bit more fuel into the engine from what we normally find coming from our typical air or fuel model if we're in the model mode, or from our traditional fuel table if we're in the traditional mode. So the post-start is a temporary increase in the injector pulse width based on what we specify here. So how much percentage increase, this is a percentage, to the base pulse width coming from our air and fuel model or our traditional table value. We hold the value for as long as we specify here, so we hold that percentage of increase for this period of time, and this is our time. And then we decay it away, as we can see in our graph here. We start to decay away, and that's specified here in our decay table. So pretty easy how these all fit together as we see that graphically plotted. Now, what we're finally left with here is our warm-up enrichment table. We can find that's going to be the last portion of our graphical plot until it tapers to 0 enrichment. And on a warm engine, typically 140 to 160 degrees Fahrenheit, that's when we're going to consider the engine to be warm. And we're riding purely on our air and fuel model here if we're in the model mode, or we're riding on our traditional fuel table values and going through those calculations with the traditional mode. So if we take a step back here, this warm-up enrichment is used as a transitory between the post-start and when the engine is warm. Now the reason why we have a warm-up enrichment table is we have a phenomenon called wall wetting. When the engine is cold, we typically need more fuel delivered to the engine. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.